Triangle S and triangle L are scaled copies of one another. Triangle M is also a scaled copy of S. The scale factor from S to M is 3/2. What is the scale factor from M to S? So this is one of those problems where we need to read really carefully, right? So we know that the two triangles that we see here are scaled copies of one another. Great, except that what we're actually asked to work with is triangle M, which we don't have a picture of. And all the information that we have, for example, saying the scale factor from S to M is 3/2, is also referring to a triangle that we actually don't have a picture of yet. And the same thing for the question itself, where we're asked to find the scale factor going the other direction, it's referring to a triangle that we don't have. For me, I like to actually have an image, and so I did figure out and sketch out the other triangle. So the way I figured this out was I measured and I said, how long is the distance across the base of triangle S? And I realized it's 2. And then since I know that the scale factor is 3/2, I multiplied. So I used that. I went from S to M and I multiplied by 3/2. So if you do 2/1 times 3/2, that gives you 3, and that's how I knew that the base of triangle M was actually 3 units across. So that was helpful to me because now I actually knew the distances themselves, and I could use that to help me figure out the rest of the information. So now that I know the distances, I can go back and actually calculate the scale factor from M to S. So notice we're going the other direction now. We're going from M to S. Now keep in mind, from M to S is a shrinking scale factor. So when we were going the other direction from S to M, it was growing, and so we wanted a scale factor greater than 1, but because this one is shrinking, we are anticipating a scale factor that's between 0 and 1. So I'm going to set these up. I'm going to take my new measurement, my new value, which is 2, and I'm going to set that over the original measurement, which is 3. And so the answer you should have chosen was 2/3. If you chose 1 1/2, which is equal to 3/2, then what I think happened is that maybe you looked at these triangles the way they are and you said, well, I'm going from M to S, so it's going to be 3 divided by 2, rather than keeping in mind that we need to start with the original. The original value is what goes in the numerator, and your new value goes in the denominator. And a way for you to check this for yourself is to keep in mind the fact that we were shrinking, right? We were shrinking in this case. We had the triangle M was larger than S, and so we were shrinking it down, which meant that we should have known something was wrong when we came up with a value for the scale factor that was greater than 1. Said, ooh, something's not right here. And that would have been a good way to know that we needed to check something.